Hello students, welcome back to Learner Science Q&A. We are here with yet another lecture series from chapter 1, class 9, Matter in Our Surrounding, part 2. Students, during our last lecture, we have already discussed about the characteristics of different state of matter. We have already seen that a matter can exist in three different state: solid, liquid and gases. We have seen the characteristics possessed by them. Now let's see some more question in this series. Coming to which physical state of matter do the following statement applied? This is in reference to the characteristics that we have already covered in our last lecture. If you have not went through it, please go through it. Only after then you will be able to answer this. So the question says, to which physical state of matter do the following statements apply? Incompressible, no fixed shape, and compressible but no definite volume. So, coming to the answer, liquid are incompressible. That means you cannot change its volume. But yes, they have no fixed shape. Shape is not fixed in case of liquid. They take the shape of container in which they are kept, and they are incompressible. Coming to next, compressible but no definite volume. Gases can be compressed to a good level, and this is the reason why LPG is coming compressed in cylinders. We have deodorants in which gas particles are compressed in small bottle. We have so many mosquito repellents, air freshener as the example, where we can see that gases can be compressed to a high degree, yet they have no definite volume. That means they go in air, they spread to their maximum as soon as the pressure is released, as soon as they are made free. Next question is, which state of matter we have layers of particle which can slip and slide over one another? The answer is liquid. The particles of liquid has tendency to slip and slide over one another, and this is the reason for their fluid nature. In which state of matter particles just move around randomly because of very weak force of attraction? Always remember, when we are talking about the very weak force of attraction or the least force of attraction, the example or the answer would be gases. Now, what happens when a matter is subjected to temperature or increased temperature? Yes, it changes its state. So, suppose temperature is applied to solid. We have studied that the particle of matter has their own kinetic energy. So, right now we are talking that when temperature is applied, so the temperature when applied to solid, the kinetic energy possessed by the particle increases such that they start vibrating very quickly. And when the temperature increases further, they start vibrating with a greater speed such that the energy supplied to them by heat overcomes the force of attraction between the particle, and that make them leave their fixed position, and they start moving more freely than earlier. And at this point the solid tend to melt into liquid, the temperature being higher, pressure being the atmospheric pressure. And at this temperature, when a solid melts to liquid, we know it as melting point, also known as fusion. So, when a solid is subjected to a higher and higher temperature, it tends to lose its rigid nature. The molecule vibrate with a greater speed such that they are converted into liquid. Similarly, when a ice melts, its temperature remains the same. Suppose we have a beaker, inside the beaker we have ice. Once in the starting, when the temperature is increased, it starts to melt, and when the temperature is further increased, it goes on melting. But still at that time the temperature remains the same. So where does the heat energy that you are providing it by giving it to more and more heat is going? So, during melting of an ice, when a solid is heated and the heating is continued, the heat energy that is being provided to the ice is used up in changing the state of the matter, is used up in changing the or in overcoming the force of attraction between the particles, and this heat energy is absorbed by the particle of the solid, in this case absorbed by the ice, without showing any rise in temperature. It is considered that this heat that we are providing it continuously is getting hidden into the content of the beaker, and this heat is known as the latent heat. That means when a solid is heated, the energy is used up in converting the solid into the liquid. That means it is used up for overcoming the force of attraction between the particle, and for this reason we don't see any rise in the temperature. And this heat is known as latent heat because it is in a hidden form. So, what is the latent heat of fusion? Always remember, when a solid is converting into liquid, the process is fusion. And what is the latent heat of fusion of ice? So, the latent heat of fusion is the heat which is required to convert 1 kg of solid into liquid at its melting point without changing its temperature. For ice, it is 3.35 into 10 raised to power 5 joule per kg. Now, what happens when water is heated? We have already seen that when ice is heated, it melts into water. Does something similar to this happens when water is heated? Let's see. Water changes into vapor. We already know this. We have seen this many times. That means when a water is heated, again we are supplying it with the heat energy. So its particle also start moving faster. And after some time, a point is reached when they have enough energy to overcome the force of attraction that are binding them together. That means the water starts changing into gas or the water vapor. Always remember, this happens when a continuous amount of heat energy is provided to water. So, the temperature at which a liquid starts boiling at atmospheric pressure is known as its boiling point. And we already know water at this temperature, for water, the boiling point is 100 degrees centigrade or 373 Kelvin. That means whenever heat is being provided, the change of state is taking place. From solid, it is going towards the liquid. From liquid, it is going towards the vapor. So, is this the reason why a steam causes severe burn? Because steam is having extra energy than a hot water, and steam is having extra energy in the form of latent heat of vaporization. So, this is the reason when you get a burn from steam, it is more severe. Now, what can be inferred from these two examples? First, from these two examples, we can infer that the state of matter can be changed into another state by changing the temperature, rather increasing the temperature. Just see in this figure, we have solid. When it is being heated, it has a latent heat of fusion which is not showing temperature increase, but it is helping in overcoming its particle losing that force of attraction, or overpowering that force of attraction that is keeping it bound as a solid, and it is getting converted into liquid. Similarly, when liquid is heated and on continuous heating, temperature remains constant while the liquid changes into gas. And this hidden energy, which is in the liquid when it is converted into a gas, is known as the latent heat of vaporization. Then, are there any solid that bypasses the liquid state while giving temperature and changes to directly into the gases? That means we have seen a clear sequence that a solid upon heating gets converted into liquid, and a liquid upon heating is getting converted into gas. So, are there any solids that do not undergo liquid state and they are directly converted into gas? So, one example we have as the camphor. There are other example also like dry ice. So when a camphor is there, it changes its state directly from solid to gas, and during this change, it doesn't go to liquid state. And this process, when a solid is directly converted into gas, is known as sublimation. Also, a gas can be directly converted into solid without getting a state like liquid, and that process is known as deposition. Now the whole phenomenon can be explained with the help of this figure. We have a solid which upon heating converted into liquid, and the opposite process being the freezing. Again, a liquid upon heating gets converted into gas, the opposite process being the condensation. And also, we have solid which can be directly converted into gas by the process named as sublimation, and gases when directly converted into solid by the process known as deposition. So, students, that's all for today. Hope you like it. Please like, share, and subscribe to this channel. Thank you.